This question is from GATE Mechanical Engineering of 2012. This is question number 14. The question is limit x tends to 0, 1 minus cos x upon x square. So we need to find this limit. Let's write down the limit here. Limit x tends to 0, 1 minus cos x upon x square. Now if we substitute the value of x in this limit, in this function, we'll get 0 upon 0. So this is a 0 by 0 form or indeterminate form, and these type of limits can be solved using L'Hopital's rule. L'Hopital's rule. Okay, now let's understand what L'Hopital's rule is. So suppose we have a function, we have a limit x tends to, let's say, a, and an indeterminate function f of x upon g of x. Okay, now if this function, this complete function f of x upon g of x is of the form 0 upon 0 or infinity upon infinity, we can use L'Hopital's rule. Okay, now according to L'Hopital's rule, we can write this function as limit x tends to a, and we can simultaneously differentiate the numerator as well as the denominator. So f dash of x, the first derivative of f with respect to x, upon the first derivative of g with respect to x. Now suppose again if this function is indeterminate form, so again we can differentiate it. So we can write that as limit x tends to a, and this will be f double dash of x upon g double dash of x. Okay, and we can keep differentiating if we are still having this indeterminate form 0 by 0 or infinity by infinity. Now let's use this L'Hopital's rule to solve our problem. It is limit x tends to 0, 1 minus cos x upon x square, right? Now we'll use the L'Hopital's rule and we can write limit x tends to 0. Now if we differentiate, let's differentiate the numerator first. 1 minus cos x upon d upon dx of x square. So this will be equal to limit x tends to 0. Now first derivative, so this will be 0 minus, and differentiation of cos x is negative sin x, so this will be positive sin x upon, this is 2x. Now again if we substitute x is equal to 0 in this function, we'll get 0 upon 0. So again we can use L'Hopital's rule here. So we can write limit x tends to 0, d upon dx, the first derivative of the numerator, so this is sin x, upon d upon dx of 2x. So this will be equal to limit x tends to 0, and sin x differentiation is cos x, and 2x will be 2. Now if we substitute the limit, we'll get 1 upon 2. Okay, so this is our answer. Let's go back. So the value of this limit is option B, 1 by 2. For more information, you can refer to NPTEL lecture number 24, L'Hopital's rule, part 1 on basic calculus 1 by Professor Arindam Singh of the Department of Mathematics at IIT Madras.